we're going to talk about Maven. Maven as a building tool. It's owned by Apache. Apache is a name of a company that builds Maven. So Apache Maven is always called Apache Maven. Is a tool, is a build automation tool, and it's for project management. For project management tool because it manages the project for you. Once you create it, start as a project. Your software is a project. It manages that project for you. It simplifies the process of building and managing Java-based projects. Okay, like I said, Maven is for Java. Okay, so if they ask you what build tool do you know or you're familiar with, it's a Java build tool called Maven. Okay, Maven provides a comprehensive set of features for project organization, dependency management, and continuous integration. So I will show you this. We are learning Maven today just as a single tool, but in most cases, we're going to come back to Maven again when we do integration with Jenkins, right? So this is just us studying Maven as an individual tool. Maven comes with dependencies, right? So when you're writing a pom.xml file, we'll get into that. It has its dependencies, so you can manage dependencies and you can use it in a continuous integration pipeline, right? That's mostly what it's used for. Mostly you don't use it individually. You can use it individually to build an artifact, but mostly you use it on a pipeline as a DevOps engineer. So the question is, what is Maven? So like I explained earlier on the overview, Maven is a build tool that helps in project management. The tool helps in building and documenting the project. In this case, project management is a manual process. Maven does project management automatically, right? When you want to automate the process. Build tool is essentially for the process of building. It is needed for the following processes. First, generating source codes, generating documentation for the source code, compiling the source code, packaging of the completed codes into a jar file. It could be a jar file, it could be a WAR file, it could be an EA file, right? Enterprise, those are enterprise applications. So this is a standalone application. This is a jar file, right? Then you have a WAR file, web application. Those are web application files, right? Or it could be an EA file, which is enterprise applications. You can package them into any of those files. Installing the packed code in local repository, server or central repository. We'll talk about this. Maven has a local repository. It also has a central repository, right? So after you package it, it can store those artifacts. After it built it, you can store the artifact in a local repository, or you can also store it in a central repository, right? A lot more about Maven. Maven is written in the Java and C# and is based on a project object model, POM. So pom.xml is the main file that when you write your codes, when you're trying to build a project, the main file is pom.xml, right? It's called pom.xml. So that's what we're going to talk about here. One thing that you need to know, if you've not heard anything about Maven, is pom.xml. Everything is associated with pom.xml. So pom is an XML file that has all the information regarding project and configuration details. When we tend to execute a task, Maven searches for the POM in the current directory, right? The tool is used to build and manage any Java project. So when you do Maven MVN package, MVN validate, what is going to look at is the pom.xml because all your codes are in pom.xml, right? We will get into the autonomy of pom.xml so you can see the contents of it. And again, you are not responsible for writing the codes. So I'm not going to delve into how you write pom.xml. The developers do that. Once they develop their code, they develop an XML file, like Maven XML file, pom.xml file. So we're not going to learn how to write pom.xml, but I'll show you the contents or the autonomy of pom.xml, so you know the contents. So if you see anything like that, you know exactly what what it is. Okay. Again, I think we've talked about this. It's a project management tool such as Maven provides a superset of features found in a build tool. In addition to providing build capabilities, Maven can also run reports. It can run reports, it can generate a website, it can facilitate communication among members of the working team. That's what Maven does. And this is the architecture of Maven, right? You have a local repository, right? Then you have a remote repository here. Now, this is the engine of Maven that has the pom.xml, right? So all the projects are in here. And once it's executed, you can also create a site. You can create a site to host your artifact, right? If you run Maven MVN site, site, that would create a site that would host your artifact for you, right? So it has a local repository, it has a remote repository, then it has the engine, right? The build system where the pom.xml file lives, right? Then you run all your commands to build the artifact in your engine. And after that, you can create a site and that will host the artifacts for you, okay? Then you can store your artifact in the local repository, or you can push it to a central repository, right? Or you can push it to a repository that you build in your pipeline. Yeah, so that will be connected with either your remote repository or your local repository. So you can retrieve it from wherever you want to retrieve it from, okay? So, but when we build the artifact would reside in our local repository, right? I will show you all that when we run the program. Okay, now there are different tools. There are different build tools. Maven is not the only build tool. Like I told you, different programming languages have different build tools. And I put together different build tools here so you can have understanding. If you get to your workplace and the developers are developing with different languages, right? At least you should have an idea what build tools can be used. So there are several build tools available for various programming languages and frameworks. And most programming languages, you'll not hear them say for these programming languages, this is the build tool. They always have what they call a framework, right? They have a framework like Spring Boot framework for Java, right? When you're using a framework, Spring Boot framework, they refer that to the framework that they use in building Java codes. And that build tool will be Maven or Cradle or Ant, right? So you have different build tools here. For this one is Maven, which is the one that we're studying. The build script is pom.xml, which is the main file that controls the build process. And its project object model is built with an XML language, which is, and they call it project object model. That's the build script. Then you have Cradle. Cradle also, you can use Cradle to build Java programs as well. This build script is build.gradle, which is a Groovy language. They use a Groovy language. When we get into Jenkins, we're going to write some Groovy languages, right? You'll see how to write a Groovy language. It's quite similar to Cradle. Then you have Apache Ant, right? Ant has the build script for Ant, Apache Ant. So the same company that builds Maven, they're the same that builds Apache. Apache and Ant has similarities. The build script is build.xml. So if you see that all of them are used, both of them use XML, right? The only difference between Apache Maven and Ant is you can write 1,000 code in Apache Ant. When it comes to Apache Maven, you can write 400 codes, and it takes care of the 1,000 lines of codes that you write in Ant. So it's more or less a superior form of Apache Ant, right? A modified Apache Ant is Maven, right? So there are people that are still specialized in writing in using Apache Ant. So those developers are still building, they can still build the artifact using Ant. Okay, so there are other different build tools as well. One is called the make, and the build tool itself is called make, and the build script is makefile. Then you have MS Build, which is the Microsoft build tool. The build script is .cs project file. Usually it's a .NET project. All the .NET programming languages, right, use MS Build tools. Then you have the NPM Node Package Manager. This one is quite popular as well, right? Because it uses JavaScript. Those that write JavaScript use NPM to, those are mostly web applications, right? Web applications. Maven can also build web applications, but this is a JavaScript. So JavaScript, if you're writing your HTML codes and you're using JavaScript, right? So you can use NPM to package that application. Another one is Yarn, right? This is JavaScript as well, right? The build script is package.json. So you can use this for JavaScript as well. Apache has another one called Ivy, right? I don't really know this one that much. It's often used with Apache Ant in combination with Apache Ant. Since I've not used Ant before, I've not dealt with it, so I don't know Ivy. Another one is Simple Build Tool, SBT. SBT tool is used for Scala. There's a programming language called Scala, and the build script is .sbt. Then you have CMake. Build script is CMake list. You have Rake. Rake is also used for Ruby. You guys have heard about Ruby programming language. So the build script is Rake file. Then Grunt. Grunt is another one. It's still for JavaScript. The build script is Grunt file. You have Gulp is another one used to build web applications with JavaScript. The build script is Gulp file. Then Bezel. I don't know much about Bezel, but the build script is build file. Bulk is another one. Apache Builder is another one. Build script is bulk build file. Then you have Rust. Build script is Cargo TOML. Then you have Leningin, Dob, Dobo. Yeah, so these are all that I listed so that you get familiar, at least know about them, that this exists. So if someone asks you, you are not totally lost, that the only build tool that you know is Maven. But if in an interview, they will ask you, if they ask you what build tool are you familiar with? Maven is the build tool that you're familiar. And the use of this build tool, if you know how to use Maven, the other one is the same. Probably the syntax might change. The commands to run them might change, but it's the same. It's like driving a Volvo. You can also drive a Mercedes-Benz. The brand names are different. The packaging are the same, but the brand name, it has a gearbox, it has wheels, it has the body, but how the brand is different. That's what it is. So if you know how to install Maven, configure Maven, you should be able to configure these other tools as well. Okay, let's compare. There are three that I want to compare. I just want to make a comparison between Ant, Maven, and Gradle, right? You can read through this. Let me go through it real quick before we get into the real deal. So Maven uses an XML-based configuration, right? This is Ant. Ant uses XML for build script. It has flexibility. Ant is highly flexible and allows for fine grained control. Ant does not have built-in dependencies like Maven, right? Plugins. Ant relies on external plugins for external functionalities. Learning curve. Ant requires a steeper learning curve due to its flexibility. Build speed. Ant builds from scratch each time, which can lead to slower build times. Now, this is Maven. This is the one that we are going to study. Convention over configuration. Maven follows a convention over configuration approach. Standardized project structures, build, cycle, reduce configuration. So we'll go through that build cycle. So you see the build cycle of Maven, and it really reduces the configuration of how you configure for it to be able to do the build. Maven has robust built-in dependency management, and I'll show you the anatomy of it so you can take a look at it. Centralized repository management simplifies dependency resolution as well. When it comes to plugin, Maven has a wide range of built-in plugins. These plugins can be customizable. The plugins that is the plugin that helps you integrate with other tools like Jenkins. You can integrate it to be able to do a continuous integration. Maven defines a standard build lifecycle. We'll get into it. You can do Maven, MVN clean, compile, test, package, site, etc. Those are the build lifecycle of Maven. We'll get into a little bit into that. Users can bind plugins to specific phases in their lifecycle. Then how about the learning curve for Maven? Maven has a moderate learning curve, right? You'll see that it's not that complicated, right? These are just theories, right? Give me 1 second real quick and I'll be back. Okay, so that's Maven. We can also compare Gradle. Gradle uses a Groovy language, right? Gradle uses a Groovy DSL, which is a domain-specific language for build scripts. It's different from Ant or Maven. Ant and Maven use XML. Build scripts are concise and expressive. When it comes to flexibility, Gradle provides a balance between convention and configuration. Developers can customize build extensively. Similar to Maven, Gradle has strong built-in dependency management. It supports what is called transitive dependency resolution. Gradle has a powerful plugin as well, and the plugins are flexible. Gradle allows for custom build life cycles, just like Maven. So they have a lot of similarities. When it comes to a learning curve, Gradle has a moderate learning curve. It's not that complicated as well. You use Groovy syntax. It may be unfamiliar to developers because they're not used to Groovy syntax, but it's very simple. Groovy syntax is very simple. And we'll use that in Jenkins so you can see exactly what Groovy syntax looks like. Build speed. Gradle is known for its incremental build features, reducing build times, just like Maven as well. So those are 3 popular Java programming build tools that I want to introduce you into. So there are developers that would choose to go with Groovy, developers that choose to write codes on Ant, or developers that choose to write codes on Maven. Whichever they use, it's used for building a Java based programming codes. Okay, all right. What problem does Maven solves, right? So Maven, getting the right jar file for each project, as there may be different versions of separate packages. So when you're doing a build, there could be different versions of packages. So what problem Maven solves in this case is that it can build your jar file, it can build your WAR file, it can also build your EAR file. I told you jar file is a standalone application. You want to create a standalone application just for your laptop or computer, right? Remember when programming started, you can buy a CD and install a program on your laptop, right? So there wasn't anything like a web, right? Web applications or software as a service. There was, if you want to buy any application, you get a CD, right? And you install it, Those are standalone applications, right? Now we also have WAR files. Those are web applications. That's more popular now. Most applications are web applications now, so they are shareable, right? Then there are other applications that only enterprises uses. Like Boeing has a software that only employees in Boeing use, right? And other companies also. Those are enterprise applications that are built just for the enterprise, right? It runs on the local web, it doesn't go on the World Wide Web, right? So those are EAR applications, EAR. So you have JAR applications, which are standalone applications, have WAR applications, which are web-based applications. Then you have the enterprise applications, which are EAR applications. So we can download dependencies by just visiting the MVN repository.com. So developers, when they okay, what is a software or what's an application? Application is a combination of the artifact or the codes that are being written and its dependencies. Every software has dependencies, right? If you, for example, if you write a program, you want it to be on the web, right? The web structures, you're not the one that developed the web structures. The web structures were developed by other developers, right? But you want to borrow those web structures into your programming to make it a web application. Those are examples of dependencies that you pull in from somewhere else and add it to your code, and now it becomes a complete package of the software. So it's a combination of the codes written and the dependencies that makes it a complete application or software, right? So what Maven takes all the dependencies that you may need and put them in one place, and that is in MVN repository.com, right? So you can go there, developers can go there and pull the dependencies they need and use it to build their package, okay? Also, another problem it solves is it helps to create the right project structure, which is essential for execution. There's a structure that it's more or less like a framework, right? I'll show you all that. It's like a framework. So once you have that framework, right, you can just go in and plug in information that you need. It's more or less like a template. It gives you a structure. So every time you want to build a program, you use the same template. So it's like copy, paste, copy, paste, copy, paste. You ask you a few questions, you put those questions, what you want to do, and Maven would build that artifact for you, okay? All right, so just giving you a whole overview of Maven. It's not like you're going to write any code with Maven. It's not your job, it's the developer's job, but you need to know about the build tool, okay? Another characteristic of Maven that we've talked about is dependency management, which I've already talked about. So Maven manages project dependencies automatically, right? So that's one of the things. Maven simplifies the process of adding, updating, and resolving dependencies, making it easier to manage projects. That's a core advantage of using Maven. So build lifecycle plugins. So like I said, every tool has a plugin. And what does a plugin do? Plugin extends the functionality of the tool. If you have, for example, Jenkins has so many plugins. You can use Jenkins to do a whole lot of things because it has plugins. Plugins are more or less like dependency packages that you bring into the tool. And instead of doing A, B, and C, the tool would do A, B, and C, D, E, F. So it would not only stop on those functionalities built for that tool, it can do any other thing that every other programmer or developer has developed. It has a plugin that can attach to the API of those other tools and can use those functionalities. You can pull those functionalities into the tool, right? So those are plugins. So Maven defines a standard build lifecycle with predefined phases. It can do a compile, MVN compile, test, package and installation, right? Just at once, right? If you do a MVN package, it's going to do a compilation for you. It's going to test your code and it's going to package your code. If you do MVN install, it's going to start from compile, test all the way through and it installed your application as well. Plugins provide the functionality for each phase of the build lifecycle. So these are build life cycles that Maven goes through. I have a slide for that as well. Maven extensive plugin ecosystem allows customization and integration with various tools and technologies. So that's what I was talking about. Okay, consistent project structure. I talked about this, like it's like a layout or a template, right? It has a template that you go in all the time and all you need to do is update that template. So that gives it the best practice that every time you know exactly what you build, everybody knows exactly what the structure of the project would look like. And this can also be integrated with CI/CD pipeline. Like I told you, Jenkins is the one that we're going to study. The other CI/CD, that's continuous integration tools as well, like the Travis, like the Bamboo. You can also integrate Maven with these tools. Continuous integration servers can execute Maven commands for building, testing, and deploying applications. And when we get to Jenkins, you'll see how we integrate Maven with Jenkins and use the Maven commands in Jenkins to build the artifacts. Okay, these are some of the benefits of Apache, which is what we've already talked about, some of them, like the extensive plugin ecosystem, integration with continuous CI/CD pipeline, right? Modular and scalar. Maven support modular project structures. Modular project structures means you define a model and you can reuse it over and over and over. For example, if you're trying to do, you want to validate your code, right? You create a model. That's a model right there, right? So it's modular. You create that model and you can call that model anytime you want to. For example, you want to call it to, if you want to test your code during packaging, right? You can call with packaging, you can do MVM package, and it will already call the validation process, it will call the testing process, and so on and so forth. So that is doing that automatically, calling those models automatically, and it's scalable as well. Automation in building. It has a automated process of building, reducing a lot of effort and minimizes errors as well. All right. So we've talked about consistent handling of dependencies and resolution of dependencies. All right, so this is a summary of Maven. Maven Apache is a popular build automation and project management tool for Java-based projects. It's a Java-based project. It simplifies the development process for managing dependencies, defining project structures, and automating builds. With its extensive features, Maven improves project organization, promotes best practices, and enhances collaboration. Maven can also be integrated with a continuous integration tool and large plugin ecosystem. So that's all we talked about Maven. That gives you the overall concept or overall idea of what Maven does, right? So now we'll get into a little bit into the details of it. We'll install Maven, right? Install Maven, and actually, I have in my GitHub, I have a pom.xml file. We'll run the file and we actually see how Maven is used in the building. We're going to repeat the process when we study Jenkins, when we integrate the entire tools, and you see how it is used in a pipeline, right? When we automate it for a build, okay? We've done this, we've done the summary. Okay, there are some terminologies that I want to introduce you to in Maven, right? But before I do that, let me show you a typical, okay, this Maven standalone project. Okay, let me show you. This is my pom.xml. Right. This is what the structure looks like, right? This is a typical Maven pom.xml project, right? It has the project, right? It has dependencies. You see a lot of dependencies here, right? You have the build here, right? It has plugins, right? So this is the contents of this is what we're going to talk about. See these dependencies has a JUnit. JUnit is used for testing, right? It has a Sonar here. So this is an extension of when we talk about the plugin. Sonar here is a Sonar Cube, right? Sonar Cube is used for testing, code coverage, right? This is a plugin that you can plug in into pom.xml, right? And this would do the Sonar Cube code checks for you automatically. So it has this. So this is a group ID. You start with a group ID. So when developers go in to this template, right, it doesn't look like this. It's a software that you go into, right? We're not studying the writing of, so I'm not going to show you that. You have a snap. So this is a snapshot, meaning a vision, right? You start with a group ID. You have to, it's a com.empty. Usually you leave it at com.empty. Then the artifact ID, is it a standalone application or is it a web application? Whatever you develop, you write the syntax here. And you have a snapshot version of this, right? Which you can also link with your Nexus as well. What kind of packaging do you want? You want a jar file, or you want a WAR file, or you want an AIR file? This is where you define your packages, right? So let's go in and look at these features. Yeah, so the features are here. So that's what I'm explaining, right? So project, in Maven, a project is a software project that is built and managed using Maven. It represents the entire software development effort and may consist of multiple modules. So when you're talking about project in Maven, that's what the whole project is called, project. The whole thing that you're doing is called a project. Then I've talked about pom.xml, which is a project object model. It's an XML file. That's the file that I just show you that resides in the base directory of project. It contains configuration information for Maven and serves as fundamental unit of work in Maven. So pom.xml includes details such as project dependencies, plugins, goals, and other project-related settings, just like I showed you. So a goal in Maven represents a specific task or operation that can be executed during the build process, right? Take note of all these terms. So if in an interview, all they're going to ask you, they're not going to ask you to write any code in Maven. They'll just ask you, what do you know? What is pom.xml? What is a goal in Maven? Those are the things that we'll ask you. When we talk about project, what do you mean by project in Maven, right? They're not going to ask you to write any code. These are the theories. That's why I'm going through these theories with you, okay? So they will ask you, what is the build tool that you know? You say Maven. Okay, so in Maven, what do you know? What's a pom.xml? What is a goal, right? So that's why I'm taking time to explain this to you guys, because work interviews, that's exactly what they're going to ask you. Nothing more, nothing less. Okay, so that's a goal. An example of a goal includes compiling, running the test, packaging artifact, which I'll show you. We'll do it practically so you know exactly what it is. Your goal is, what do you want to do? I want to compile the code. What do you want to do? I want to test the code. What do you want to do? I want to package the code to an artifact. What do you want to do? I want to move the package to a site, right? So those are individual goals. So when you talk about goals, those are goals in Maven. Still some more in the terminology. You have a plugin in Maven. A plugin in Maven is a collection of one or more goals. Plugin extends Maven functionality by providing additional tasks that can be executed during a build process. Plugins are configured in pom.xml or POM file, and Maven uses them to perform various functions. So we've talked about plugins, it's just to extend the functionalities of Maven. You can do code coverage. You can use it to do testing, like JUnit testing, like I showed you in the pom.xml file. So a repository in Maven is a storage location where project artifacts and dependencies are stored. there are two types of repositories. So when we look at the architecture, I showed you have a local repository and a remote repository. So local repository stores artifact on the developer's machine. So like when we run artifact, when we run Maven right now, it will create an artifact, and those artifacts will be stored in your local machine. Maven also has a remote repository, right? It's hosted repositories that Maven uses to download dependencies not found in the local repository. So the first time when you run MVN, for example, MVN package, Maven will look for the dependencies in your local machine. When it doesn't see the dependencies in your local machine, it would go out to the remote repository, because that's where all the dependencies are stored. So let me see if I can MVN repositories. I think this is, yeah. So this is the remote repository, right? You have all the dependencies of Maven stored here. And these dependencies are what is used. The developers come here and pull these dependencies, like Android packages, logging framework, Java specification, JSON libraries. It has all kinds of, so they come here and pick the dependencies to create the packages. Now, whereby, so when Maven will do MVN package to package your artifact, when it looks at your local repository, it doesn't see the dependency, you will go out, because some of the dependencies are being referenced. You go out to MVN, the remote repository, mvnrepository.com, and pull those dependencies into your artifact. Okay, so that's local repository and remote repository. Lifecycle, a lifecycle in Maven represents a series of well-defined phases that a project goes through during the build process, like the MVN clean, right? MVN validate, MVN compile, MVN test, package, install, and deployment. Those are life cycles. Those are defined as life cycles. So these are all theories that you should know. If they ask you, what's the life cycle in Maven? What does it represent? Life cycle in Maven is nothing more than a cycle of creating an artifact, which it goes through MVN clean. Clean would wipe every other artifact that was built already, give you a clean slate. Then validate. Validate will go in and validate all the codes and make sure the codes are okay. If there's any mistake in the code, it will flag it's not going to run. It's going to stop and give you a message that there's a problem in your code. This is just checking the syntax of your code to make sure the codes are running okay. Then Maven also compile. It has a compiler inside that will compile the code. Now I compile the code to an artifact. After a compilation process, it goes through a testing phase. So you can do MVM test. It tests the code and make sure that it runs. After it does that, then it packages it to an artifact, right? Then you can install it, right? If it's a jar file, you can install it as a standalone application, and you can actually run that application. If it's a web application, you can install it as well. Then you can deploy it. MVM deploy means you are deploying it to Tomcat, right? Which is a web, an app server that would actually show the application if you're deploying. You can also deploy it as a standalone application as well. Okay. So those are the terminologies I wanted to expose you to. Again, let me run through it. Project, POM, which is project object model, goal, plugins, repositories, lifecycle. So those are the terminologies that you hear in Maven and you should also know about. Okay, so this is the packaging. Every packaging that I told you, the standalone application is a jar file. Your end of your file could be an ebay.jar. If you're building an application for eBay, the extension has to be .jar because it's a standalone application. It could be PayPal.jar, it could be RBC.jar, whatever, renders.jar, whatever program you're writing. The extension has to be .jar. Then you have a web application. If you're developing a web application, it ends with an extension WAR. So Bank of America.WAR, RBC.WAR, right? So it ends with that extension. And enterprise application ends with an EA file, right? American Airline.EA, Bank of American.EA, TDBank .EA, TD.EA. However you want to package it, it must end with a .EA extension. So standalone application, web application, enterprise application. And all these applications, they come as a bin file, which means that they are zipped, right? They all come as a zip file, right? So you have it a zip file or a tar file, which if you want to actually see the content, you have to unzip it, right? So when it builds it, the final one will be like a bin file, which are all archives, right? So the archives can be stored away, and when you want to use it, you can pull it and use it. Okay. What did I want to specify in this? Java code only contains only Java classes. So you have Java classes. Example, if you're running a standalone application, it has Java classes. Don't worry about this. These are for developers. So this is a standalone application. This is a web application. Now, web application, to write a web application, you have to write it with a HTML code, right? Then you can use JavaScript, right? JavaScript to control it. Then you can use a CSS file to style it. And you can also put images. I think last class I showed you an HTML file with CSS and JavaScript that I developed, right? And you can also have a backend code as well, as well that can also be packaged. So when you have that, this complete a standalone application. Okay, so that reminds me what I wanted to talk about in this. So Java file, standalone application just has a class file, just a class file of Java program codes that you write, right? That's the only thing. But when it comes to web application, it has all this content within the web application, right? And you can package it as a WAR file. Then you have an enterprise application. Enterprise, have a question? Do you have a question, David?
Oh, no, sorry. I didn't know my this was on mute.
Yeah, then enterprise application is a combination of WAR file and JAR file, right? Because you are an enterprise, say a bank, maybe Chase Bank, develop an application for Chase Bank, only to be used internally by Chase Bank, right? Once, because it has to be a web application for internal use, right? And it also has to be a standalone application because every individual has to have its own application, right? But it's also distributed, meaning that in the web, is an internal web within the enterprise. So it's a combination of a WAR file and a JAR file. And you can also use a Maven to build that as well, right? So that's a standalone application, a web application, and an EA application. All right, what are we building, right? So what are we building? What we build is a build script, which is, it ends up with a build script in pom.xml, and it's a Java file. You can do a test, right? First, you have a source code. The source code is the code that you have written, right? Then inside the source code, you have a test. You can run your test, right? Inside the source code, like in pom.xml. Now, this is a Java program, right? This is .NET if you're using .NET, and this is C++. If you want to do a unit test after building the source code, right? So all your code will consist of the source code, will consist of also the test, and it also contains the dependencies, right? So I think I did not put dependencies here. So it should include dependencies. So it has, let's put this in this format. So it will end up being a build. So you have a source code, then you have a test unit, then you have a dependency. And this dependency would culminate, and that will give you a build script called pom.xml or pom.xml at the end. So you have a source code, you have test unit. This test unit is not going to contain this, because if you're using other programming languages, you can do just testing. So let me take this out so that I don't confuse you guys. Right. So now we're using Java, so it's going to be a JUnit test. Right. So you have a source code, you have test cases, and you have dependencies. Right. And that would make it, you have dependencies. So those are three things that you need. And that would combine it, and you have your pom.xml file. Okay, now I've talked about XML, and if you guys know a little bit about HTML, right? So I wanted to show you the difference between XML and HTML. So when you're looking at HTML and you're looking at XML, what are the difference, right? So if you notice, if you're trying to write a web application, there are some tags. HTML code has tags. So these tags, everything has to go in between these tags. Let me bring up my Visual Studio and see if I can show you a typical HTML file. Now the problem is where I store, okay, I think I have one here. Right. Okay, so this is, where's my HTML? So this is my HTML file. In this my HTML file, see, these are predefined tags. You see this tag? This tag, see this tag? These are predefined tag. If I do H1 here, it has to end up with H1 here. Have H1 here. So these are predefined tags that you use in HTML. That's this HTML. Then you also have, okay, just so you know, this is a web application. It has a CSS file, and it has have a script here, JavaScript right here. It's this CSS file used for styling. Then I have a JavaScript here just to create some functionalities to control the entire HTML. So these are codes like a web application if I want to develop a web application, right? So that's a typical web application, right? Right. So it has tags. So that's what I want to show you with HTML. It has predefined tags, right? But if you come to XML, XML doesn't have a predefined tag. The flexibility is you can create this tag, you can call it whatever you want to call it, right? You can, this is the ID, right? And this is name, right? You can call it whatever you want to call it, but with HTML, it has to be H1, H1, H2, H2, H3, H3, right? And it's not defined. When you're writing HTML, you have to come up with whatever you want to call the tag. Again, I can show you. Let's look at my pom.xml, right? So you see like group ID here, group ID, you can come up with this name. These are not predefined, right? You're just using it so you understand exactly what it is. Like URL, then you can type, because you want to know that this is URL, windowstech.com, right? You have properties. You just want to call it properties so that you understand that this is a plugin properties that you have. Sonar properties that you have here. So these are the properties of SonarQube, right? So it doesn't have, these are dependencies. You're calling it dependencies because you want to call it dependencies, right? So that you understand that this is a dependency, right? So this is an example of how it's written. It's not a predefined tag, okay? Anatomy of pom.xml, I told you I was going to show you the anatomy of it. It's nothing more than what I just showed you here. This is the pom.xml, but let's get into the details of it so you can at least know you are not responsible to write any of these codes, just to let you know, right? So it might look really overwhelming because this is the first time you're looking at it, don't worry about it. This is not your responsibility. These are the developer's responsibility. I'm teaching you this so that you know what are the contents of this Maven. So when you see it, it's not a new thing to you. Or if you're working in any organization and they have a different build tool, right? So you know that there's a file like this that goes into a build tool. That is the purpose here. The purpose here is not for you to understand or learn how to write pom.xml. Okay, so let's look at the anatomy. At least if you look at pom.xml, you know what the contents are, and you can actually explain it if you need to. But then no one is going to ask you about this in interview. So this is just for your knowledge, right? Basic structure of pom.xml. Pom.xml file is an XML file named pom.xml located in the base directory of the Maven project. So this is how it looks like, right? In summary, you start with a project is a project and it ends with a project. You close it with this project, right? And these are some of the things that goes into it, like this, this schema. This is an XML schema that you're importing from a different website. And this is you going to the central repository, Apache's repository, and getting a version of pom.xml that you want to run, right? This shows you version 4.0.0 that you're trying to pull from apache.org and bringing it in here. It defines the version that you want to run, okay? So it has a model version, the key elements have a model version. So that's the version that I was talking about. It has a group ID. You have to specify the group ID. And pom.example, that would be the group ID that you want to call it, because throughout it uses the group ID to group your applications, because you could have various applications on different files. So this uses this as an identifier that identifies exactly this artifact by the time it's being built. They also have artifact ID. Artifact IDs identifies the artifact, such as a jar, WAR. So if it's a WAR file, you include it's a WAR file or a jar file, and so on and so forth, right? Another key element in this is the version, right? What version of XML are you running, right? It has a version as well. Then packaging, specify the packaging type for the project, jar file, WAR file, or POM file. That's different from the ID here. Okay, the ID here, you provide the name of your project, right? But when it comes to packaging, you define what package that you want, a WAR file, a jar file, or jar file, or an EAR file. An EAR file. Sorry. An EAR file. Okay, so it defines it's a jar file, WAR file, and EAR file. Then, and this is how it's written, right? Then you also have dependencies, and your dependencies goes here as well. Another key element is build, right? Contains build-related configuration, including the plugins and the configuration. It goes under the build tag like this when you're writing your pom.xml. Then we've talked about plugins as well. So you have the plugins, then you can bring in your plugins. There's let me see if there are other elements that I need to. So those are the key elements. Then this is a typical example, just an example of what I showed you on my GitHub. This is what it looks like by the time you write your pom.xml file. This is exactly what it looks like. It looks ugly, but it's always like a template, right? You give you a template, you go in, it will ask you like the project, like the version, the packaging. You just plug in those information. Then you click create. Once you click create, it will create all this for you. It's a standardized process, very easy to use to create this artifact. But you need to know what you're doing. That's why developers are using it. If you enter the wrong information, it's going to flag it. I know I tried to use it once, and I struggled with it until I figure it out. Right? You need to know exactly what you're doing. Otherwise, you put the wrong information, you're going to struggle with it. But it's very simple. Once you know how to use it, it's just copy and paste, copy and paste. It's a template form of a software. So those are the elements of pom.xml, right? And the next thing you want to do is installation of Maven. Okay, so now let's install Maven and actually run a project in Maven. So we're going to use an installation script. I'm going to go to my GitHub repository and use it. You can install it in your Linux, Red Hat, Ubuntu, or CentOS. You can install it in your Windows. You can install it in Mac OS, right? But it has a dependency. The installation of Maven has dependency. It depends on a Java runtime environment. So you have to install Java as well, right? Maven cannot run without Java runtime, right? So you have to install that as well. That's packaging help Maven in the build process. So let's go to I put a link here. This is my GitHub repository. We already done Git, so you know how to fork the repository, right? So once you have this, just click on the link. The link will take you to this, and you can fork this repository, right? This is how to fork the repository. We talked about that yesterday in our Git. You fork this repository, and it'll become your repository. You can go to the main, right? Go to the main package. So this has all the installation that we're going to do in this class, right? Maven installation, Tomcat installation, kubeadm for Kubernetes, Nexus installation, SonarQube installation, Java, we can do Java installation, Docker installation. So you have all the installations. So you can go ahead and fork this repository and keep it, it becomes your repository, right? Once it becomes yours, you can play around with it, do whatever you want to do with it, right? So we've already created, you have your repository in GitHub. So all these things that I'm going to be referencing you to my repository, giving you my repository so you can fork them. I have a whole lot of repositories here, right, that I'm going to share with you. You will also fork them and make them your own repository. Okay, so there's someone that attended an interview and they said they want to see their Git repository. They should send the link to their Git repository. So they want to see how involved are you? What are the projects that you've done previously? Do you even know how to use Git, right? So when I sent you a link, try and fork it so you can develop your repository in case you run into a company that wants to see what your Git repository looks like, okay? So again, let's get back to this package repository. What we're looking at is a Maven installation, right? So this is, I have Maven installation here. I think I have it in Ubuntu and I also have it in Red Hat. Do I have it in Red Hat? If you want to run it Red Hat, probably not. Probably not. I don't have a Red Hat installation yet. Let me look at the slide. The slide might have Red Hat installation. We're going to use Ubuntu anyways. Did I include Red Hat installation? No, I did not. I just give a reference to it. Okay. I just reference us to the Git. So we're going to use Ubuntu. Okay. So now let's go to my pom.xml. Now I don't have an instance running. So if I go to my AWS, let's go to my AWS. Let me go to my EC2, go to services, my EC2 account. I don't have any instance running. So I have a Terraform instance running. I'm going to use my Terraform instance to create an instance, okay? Everybody, you all know how to create your own instance, okay? This is Terraform. None of you, or probably you don't, has attended the Terraform class, so you don't probably knows how to use Terraform. I'm assuming he does by now. So that's what I'm going to use. Where's my instance? Okay, this is my Terraform instance. So I'm going to enable it. And I'm going to show you magic of how I use Terraform codes to create an instance. Okay, let me start this instance. That might get you a little bit get your interest into automation a little bit. So let me give you a little glimpse of Terraform. We'll do Terraform is one of the classes that we'll do at the tail end. But let me show you a little magic of what Terraform can do. Now, all of you knows how to create an instance, right? If you're creating an instance, you go through a manual process of creating your instance, launch an instance, and doing all that manually. What if you want to create, you are working for a company like Amazon, and you're a DevOps engineer, or maybe you're a platform engineer, you took a job as a platform engineer, and they ask you to create 1,000 instances so that they can host all their applications, so that they don't have any disruption or in their user experience, right? So that all the applications can be running depending on the traffic. You're working for Amazon. Amazon is big, and the traffic is always, so one server cannot take all the requests. So you want to create more instances so you can install, you can configure the application in all the instances. What do? Right? You're not going to be able to start creating one instance at a time, one by one, right? So that's where Terraform comes in. You use Terraform to provision thousands of resources in AWS or any other. Okay, it's running now. You use Terraform to do that automation in creating so many instances. So in this is my Terraform. It's running right now. So let me copy this and let's just search into it now. So let's see. Let me bring back my Git repository that has the installation script. So this is the installation script. I can minimize this as well, so we can have them side by side. Move this out here. Okay, so this is my installation script. So the first thing I want to do is create a host name, right? My host name called Maven. So I copy this, I create that host name, right? Then I switch user to Ubuntu. When I switch this user, it's already Ubuntu. The only thing I want to do is so I can change my host name to Maven. Switching this user. I could also exit and come back in, and that will switch it and give it the host name Maven. Once I do that, I want to install my Maven in OPT directory, right? So I changed the directory to OPT directory, right? Now I want to install wget. Wget is used for downloading stuff from the online. I want to install Vim. Vim is like an editor. You can also use VI as well. Then I want to install tree. For some reason, this tree did not agree, but I don't really need it. I want to install unzip just in case I want to unzip a file. Then I want to install Git, right? Git, I said Git all. So it's going to download all the Git and the dependencies. I want to do this recursively. So I use a -y, okay? So I can copy this and paste it here, right? So tree, and Git sudo apt install Git. I need Git to be installed. Okay, it's already installed. I already have Git running. Sudo apt install tree, right? No app, you can use snap to install, snap install tree. Sudo snap install tree. Okay, my tree is being installed right now. Tree is just, that I've installed tree before. It's just so that you can look at the structure. You can look at the structure of your directory, right? Error opening the directory. Okay. So with tree, you can see the up directory is always secure because that's where you install all the binary files, your application files, and so on and so forth. So it wouldn't allow me to do that, right? So after that, you can do an update. You can do an update on this. Again, don't worry about if you install tree or not. It's not really necessary, right? You don't have to install tree if it doesn't want to install. Don't go through the hurdles of trying to install it. Then you can install. This is a Java environment that you need, which is the dependency. You cannot run Maven without Java. So this would install Java 8. Okay. So it's going through that. The reason we install Vim is because we want to set the environmental variable, right? So that's why we install Vim. We could have used VI, or you can use Nano, right? We study all that in Linux commands, right? So you can use Vim, you can use Nano, you can use VI. So once that is done, right, you can see if your Java is running. So you can do, what did I do? Just a second. Yeah. Okay. I needed to do. Yeah. You can do Java dash version to see the version of Java that's running. So you have OpenJDK 1.8, right? Have a runtime environment also running. So when that is done, now you have to set your environmental variable. So with using this command, right, that would open this editor for you. Now, all you need to do in that editor is to copy this, right? Do I to insert, right? Then you can come to the bottom of this file. Don't mess around with this file. This is your system files, right? You mess with it, you need to set up a new instance, right? Just copy this, right? Load the updated bash script file to apply. No. This is what not this one. This is the one that you copy and paste here. Right, this is to add the following lines, right? Export, copy this and paste this. Now, after you've done that, right, to load this, let me clear this so you can see what I'm doing. To load this, you run this command, the source command, right? So that is done, right? So verify that you have your Java. You run this just for verification. So you have your environmental variable set, right, on user library JVM, right? So after that is done, now it's time for you to install your Maven, right? You can copy all this at once. And what we'll do would update your system one more time and then install Maven, and we'll give you a version of Maven that is running. Okay. Give it a few seconds. Okay. All right, we'll stop the class today at 8:45 because we didn't take a break. Okay, but I think we should be done before then. All right, so now you see that it runs MVN version, and with that version, it shows you the Maven version that is running 3.6.3. It also shows you the Java version that is running behind the scene. Okay, so that's installation of Maven. Okay, once you do that, you have Maven installed. Okay, so now that we have Maven installed, what else do we need to do? Let's go back to our slide, right? So now that I've installed Maven, the Maven lives in the home directory of Maven is now opt/Maven, right? Because we install it in opt directory, right? We install it opt directory. So you have Maven installed here. So that's the home of Maven, right? So it contains Maven in this directory. So you want to look at your files, your properties of your files, you have to go to the opt directory and it creates this. There are some organizations that change the Maven home directory. They can change it to app, right? /Maven, you can do that as well. Install it in /app directory as well. So whatever it is, it depends on your organization. Whatever they do, know that that is possible as well. Okay, now I have a file that has a package, a file that I want to run. Now that I have, so I have my pom.xml file. So if I go to this, if I go to my GitHub, right, I have this setup. So this is what I want to run. It contains my source code, it contains the target, and it contains my pom.xml. So this is the package that you get from the developers. After they've asked you to, when they write the code, right, they write the code. Once they're done with Maven code, it will come up with this package. It will give you a source code, it give you a target, and it give you a pom.xml. The most important file here, like I said, is the pom.xml. It contains all the information that is needed to create your package. The source file is actually the code, like the main software. If it's this is standalone program. If it's a web application, you have all the web stuff. We'll look at web application when we get into Jenkins, right? We're going to deploy that application. I'll show you then. But it has all the codes, the source code that is written, right? So you'll find it here in the source code. Then the target is your target. What's your target? What are you trying to target? Basically, by the end of the day, what is it going to build? A test, and so on and so forth. A snapshot of the jar file would be moved into your target folder. So these are the three things that you have. So what I'm going to do now, I'm going to clone this. Yesterday class, we showed you how to clone a repository. We're going to clone this repository. So I'm going to copy the link of this repository here. Now, since I have my Maven running here, so I will simply come here and clone this repository. Now, I'll do git clone. Remember when we're doing the installation, where's my installation script? We're doing the installation, we install git, installation of, right? We install git as well. The reason we install this git is so that we'll be able to clone the repository, right? So now that I install git, I can do git clone, right? I copied that repository and I can paste it here. I hit enter. It denied me the right. So I can do a sudo on this because I don't have the privilege, because it's a /opt directory. I don't have the privilege to get into it. Now I've cloned that directory. So if I do ls now, you see that directory is being cloned. So what I need to do is have to change directory and go into that, right? That directory. So now I'm in that directory now. If I do ls now, you see the pom.xml file, you have the source file, and you have the target file. The same files that we had here, the source file, the target file, and the pom.xml file. Now this file becomes mine now, is in my local directory. This is my local directory. Now, since I have this file, I can do a build, right? So let's get back again into a PowerPoint. So now you get into the life cycle of Maven. Remember, we talked about the life cycle of Maven. So these are the three life cycles of Maven. You have the clean life cycle, right? The clean life cycle is a pre-clean and post-clean. So when you run MVN clean, right? MVN clean will go in and clean everything that was in there that you had built previously. If it has a dependency that is still hanging, you clean that and clear that up, right? So now you also have a default lifecycle. The default lifecycle is actually how you build. You can validate, you can initialize, you can generate the source code. When you do MVM validate, right? It initializes, generate the code. You can also do MVM compile, right? You can do MVM package, install, and destroy. So this goes into the default lifecycle. Then the site lifecycle is after you built it, Now you want to create a site for it, you want to deploy it. Now you can install your Tomcat as an application server, and you can run NVM deploy, and this application, after creating an artifact, will be deployed, and you can see your application live, right? So now, because we've already had, we have files, we're going to go ahead and run these files, the lifecycle, the default lifecycle, so we see exactly how it works. So these are some of the commands that we can run. NVM validate, it will validate the project structure. NVM compile will do the compilation. Test will test use the JUnit and do the testing. NVM package would actually package the whole thing. Then if I run NVM package, it should go ahead and do all these steps for me one by one. But we're going to run this just for the kick of it. And with that, we'll see that we'll be able to build a jar file. Okay, let's go ahead and run that. So I want to validate that the codes that I have here is correct. So I would do, let me invert my privilege here because I'm running in OPT and I had not changed the privilege. I could have changed the privilege so I can do an execution, but let's use sudo here. So MVN validate, right? Will validate the codes that I have and will give me a success, right? I'm successful. Now let me do test, NVM test to test the code. Let me sudo NVM test. I'm not sure there was a test case written to this, right? There was a test case. All right. So we had a test case and it's running the test case now. It's testing the code and making sure that the code is successful, right? So you run a lot of tests. What it's doing right now is going to the Maven Central repository and is going to pull the dependencies for testing the JUnit. That's why it's taking a long time. If we run it again, now all this testing is now in my local repository now. What it's going to do is going to fast. The build process is going to run really fast. So it has run 0, failure is 0, error is 0, skip is 0. So our build test is a success, right? Now I can run NVM package. Let me sudo it. NVM package will now build the package for me. Okay. All right. It's going to the central repository and pulling in all the dependencies. Now the build is a success, right? So it has built the package for me. So if I do ls now if I go to my target directory, so let me cd into a target directory, right? Do ls, the target directory has a jar file now. I did not show you previously, so this jar file did not exist. So this is the jar file. He has created a standalone application for me. Unfortunately, I'm going to stop right here. So that's a build process. What else do we have in our slides? Let's see, I think that's where we actually end, right? So this is the life cycle, and it has, Maven has a plugin dependencies in the build process. This is the local repository, .m2 repository, and this is the remote repository or central repository. Okay, so there's so you see that we are able to build an artifact. There's a jar artifact. We're going to continue a little bit with Maven when we get into Jenkins, when we're trying to build good integration and build a web application, right? So this is just the intro of Maven. We'll use Maven over and over and over, okay? So that's where we're going to end.